So get ready with your notebook and pen. Okay. If you want to learn subnetting, you have to calculate. Laptop is not required. So close all your laptops. Keep it in your bag. So in the last class, we have discussed about different classes of IP address. So class A, B, C, these three class IP addresses are used for unicast and broadcast. Okay, so there are three type of communication: unicast, broadcast, multicast, and nowadays we have anycast. So unicast means one-to-one communication. So whenever we want one-to-one communication, means one computer to another computer communication, we will use class A, B, C IP address. If you want to send broadcast in your own network, then also ABC means same network broadcast address. We will use as a destination IP. So for broadcast, we don't have any specific class. For multicast, we have a specific class, that is class D. Okay. So whenever we have to create a multicast group, we have to do video conferencing or that type of thing, we use class D IP address. For multicast, there is a separate course even to learn how the multicast happens and how to control and troubleshoot the multicast communication. Apart from this, in the last class we have seen what are the options we have. If any IP starts with this, or this one, or all host bit 0 or 1, we will say this IP address as a invalid IP address. So this is a short options to memorize about valid and invalid IP addresses. Now, let us discuss about subnetting. So what exactly is the subnetting? Subnetting is simply a method or technique using which we divide a single network into multiple small networks. Okay? So subnetting is simply a method or technique using which we divide a single network into multiple small networks. And what is the purpose? Wherever you see, we are talking about connectivity. We learn how to make communication between multiple networks and different networks. Here we are dividing. Okay. So why we are dividing? Simply like it happens in the family. We think about the family bonding. We want to make new friends. We want to make new neighbors, and we want to separate in family also. So both things are based on a different situation. So similarly here also we are learning the techniques how to connect multiple networks. But along with that we want to set some boundaries, some limitations. For that we have to keep things separate. We want to have privacy. Like for example, if you are in a joint family, then what happens? If you have any problem in your family, anyone is having any problem in midnight, stomach pain or anything, so who will get affected? Only the person who is having a stomach pain, correct? In the joint family, it happens like that. Everyone will wake up in the night and then say what happened, and whatever things can be done, like medicine, doctor, we do like that. Means one person is having problem, and due to that, things get broadcast and everyone get disturbed. Correct? So similarly, here in the network, if there is a single network, the problem is it if it sends broadcast message, it will go to all the devices. Whether that broadcast message means to that device or not, it doesn't matter. It will go, and accordingly, it has to acknowledge also. So lot of unnecessary traffic is generated inside the network due to broadcast communication. So to control this broadcast means you don't want to wake up in the night. What do? You shift with your family in another city in a 1 BHK or 2 BHK house. Correct? So if it happens there, I don't bother about it. So similarly, here also what happens? To break this broadcast or to control this broadcast, we create a small networks. Okay? So when we create a small network, if anything happens that affects only that small network, it is not going to affect the entire network. Understood? So if broadcast happen, that broadcast will be only in that small network. It will not go to all the networks. Why? The reason is a small network or large network, that doesn't matter. Different network, if they want to communicate with each other, it need router. Okay, router as a device it need, or any layer 3 device. Why? Because nowadays it's not only router. Nowadays firewall can also make communication between different devices. Layer 3 switch can make communication between different devices. Router can also do. So we can say any layer 3 device directly. If we use any layer 3 device, so just take an example of router, it will never allow to pass any broadcast traffic inside it. Means if router is connecting two different networks, if broadcast comes from one network, it will not allow to go in another network. If it allows, then what will happen? You will not be able to open your Facebook and Instagram. Problem, if anyone send broadcast message, it will go to all the internet users of the world. And if all is going to respond back, then you think how much heavy traffic will come to the internet and full internet will get choked. So that's why to control this broadcast, networks are divided into small subnets. This point is clear. Second thing, security. What type of security we have in a company? We want to set different policies for different department. Like you have the marketing department. So marketing department need access of everything. Everything means they need YouTube, Facebook, Instagram, like social media type of thing. But same thing if you are going to give to your engineering department or any other employees of your company, what they will do? Whole day on the laptop, they will open the Facebook and YouTube, and they'll watch movies like that. Okay. So to control this, we need different policy for the different departments. So how we can implement it? Then you will think, okay, I will put their computer's IP address and block them. So how many times you will add the IP address and make the rules? Every time, if no new person is going to join that department, again your work start. So that is the reason we make separate subnets or a small network for different departments, so that what I want exactly we can achieve. We define the policy, because one department want to communicate with another department or want to access internet, all has to come to either firewall or router. And on the firewall or router, we can define for which network which things are allowed and which things are not allowed. So that is called here security. So you can define different security policies on different network, and for that reason we do this subnetting. Okay. Next thing is, suppose in the company you have the sales department and accounts department. So sales, accounts and HR, these three are very sensitive department because they have the whole business information. Sales have all the customer contact details. Okay. Then HR have all the employees detail, their salary, how much they are getting and everything, along with their address, every information HR have. Okay. So if this information is going to be leaked, then what will happen? Company can have loss. So it is a very big crime in the company if you uh, take out this customer information and give to the competitor company. They will pay you a lot. But the problem is, if you are caught, then your company will repay you a lot also. All the legal action, cyber crime, and lot of things will apply on you. So to protect this inside the company, this department no one can access. How we can make it? When it comes to the router and want to communicate with other, we will say no. You can only go to internet. You cannot communicate internally with each other. So these all things we do, because whenever we talk about hacking or the attacks, most of the attack happens internally. External attack comes, but most of the attack happens because of our internal employees. Okay? They are careless. Like, suppose I am in the company, I have internet connection, and from my laptop it is easier to reach out to the server and everywhere. So attacker will not target directly server. Attacker will target employee's laptop, and then from via employee's laptop, if they have the control, they can go anywhere inside the network. So recently the same thing happened, and that person whose laptop was hacked was about to terminate, but anyway he was saved by the manager. His laptop was hacked around 8 p.m. in the night, and what happened? Via his laptop, all the servers storage was hacked and everything was deleted also. Complete database of the company was deleted. You see the type of attack. Immediately the entire business down. Then immediately the forensic team and all they came, they started checking from where it happens, each and every laptop. Then they found one laptop, then they found one person. So when you are working in a company, you will not be aware of, and you will be the victim. And because of your careless activity, you will get caught. So that's why when you are using your company laptop, try to work only your company job on this laptop. Don't try to visit the websites, like, not that type of website, means a general website you are searching, you are not aware of. Some pop-up comes, you accept it, like cookies and lot of things we are accepting nowadays, but we don't know that whether it is genuine, fake, any unwanted link opened due to some phishing activity, and you are not aware of. And in the background they will install any software, and using that they will access. End of the day, you will get caught. It's not because of you the things was hacked, because the thing which you have done on your own laptop, that was not allowed. Understood? So you have to be aware of this. So nowadays people are using this security and limitation. That's what they don't even allow internally communication also. They restrict a lot of things. So this security option is clear that how security is important internally. So we need to separate the networks for every department. Next is reduce wastage of IP address. So this line applies, or this subnetting is generally done in the ISP end. We also do in the company, but most of the network engineers, as they don't want to use their brain, they are not using the subnetting techniques. That is the fact, what I have seen as of now in my career. We have to learn, it is very important, but they are not using. But this one you will use in your AWS when you are creating VPC subnet. For that definitely we have to learn, and it is a good thing. So reduce wastage of IP address, as you have seen in the last session, that in one class C network, we have 256 IP address. That is a small network. Class C we use. And we have 256 IP address in class. I want to divide my network, and overall my network size is of 100 devices. I want to divide in 5. So what will happen? We will take class C 5 different networks, and every network will have almost like 250 IP address. That will be 254. Just assume at 250. So 250 multiplies by 5. It becomes 1250 IP address you are taking. Out of 1250, you need only 100 IP address. So remaining 1150 IP address you are wasting here. So to reduce this wastage, we need to do the subnetting. So here it is a free IP address. So if it is wasted also, we don't have any problem. But when we talk about the public IP address, each and every single IP address is important. We cannot waste. We cannot make it idle. So that's why in ISP end, all the IP addresses are properly subnetted. Not subnetted, they do VLSM there. Based on the requirement of customer, they calculate an exact one IP, then one IP. They will not waste even a single IP as a network. So this point is clear. Now coming to the calculation of subnet. So here we will learn only for class C. That is enough for you in AWS. So you know your requirement. You want to create how many different subnets? One subnet, two subnet, three subnets. So your requirement is clear. And always keep in mind, when you are doing subnetting, you are dividing network equally. You are not dividing that how many IP address will be in which subnet. Okay. So there are two type of calculation. One where we define how many subnets I need. Another is in which subnet how many hosts or how many devices or how many IP address I need. So these two are different things. So for the first we have subnetting technique. For the second one we have VLSM technique. Okay. So here we are learning subnetting, where we will learn that if there is suppose 1000 IP address, I want to divide in 5 subnets, means every subnet will have 200, 200, 200 IP. Equal distribution of IP address. Okay. So here just take any network ID of class C. Okay. Then the first step 2 to the power n equal to greater than. So here in notepad I cannot write equal to greater than together. So I have written like this. So it is equal to greater than number of required subnets. So this is the formula. So 2 to the power n should be either equal or greater than. It should not be less than number of your required subnet. Where this n is what? N is number of host bits to be converted into network bits. Like this is a hall, I want to make two partition, two classrooms. So which I will use? Option. Same I will use where you have put the chair to make the partition. So that's why host bit will be used as a network bit. We will not disturb the network bit. Means this boundary. If I disturb, we will be in another classroom. We will be capturing another classroom. So similarly here, host bits we convert into network bits. So 2 to the power n equal to, suppose I have taken example of 4. So 4 means 2 to the power 2. So n value is 2. Clear this one? Then this is the default subnet mask of class C. From there I have converted 2 host bits. Why 2? Because we got the value of n is 2. Then when you convert it into decimal number system, you will get this value, and this is your subnetted subnet mask. So there are two type of subnet mask: default subnet mask or subnetted subnet mask. So default subnet mask is based on the IP address class, like in the previous class we have seen. It belongs to class C 255.255.255.0. So we don't calculate directly based on the class. We write subnet mask for any IP, that is default subnet mask. And after calculating subnetting, when we are writing the subnet mask, that is called subnetted subnet mask. Okay. So this one is subnetted subnet mask. Now it's time to take the block size. So block size is what? In which subnet, how many IP address will be? So total number of IP address we have 256 minus the value becomes 64. Or another method is 2 to the power this value. How many bits are remaining? 6. So 2 to the power 6 is also 64. So 2 to the power h we say. And then minus 2. Minus 2 means one network ID, one broadcast ID, and then it becomes a valid host IP address. Once you get the block size, then the next is you know the table of 64. So first you have to write 0, then the table 64, 128, 192, and then 256. Then you are going to write the previous one. Like here it is 64, then it will end up on 63. Here it is 128, so here it will end up on 127. So similarly till 255 you have to write. So 0 to 255. So here we come to know that first subnet will be from 0 to 63. Second subnet 64 to 127. Like that we have to calculate the block size. Then here we have the range. For every subnet, we have to write the range. In every network, not only in subnet, in every network or subnet, we will have three things. Network ID. So first IP of every network or subnet will be the network ID. And the last IP will be the broadcast IP. In between IP address will be the valid IP which we can configure on our devices. But when we are configuring this IP address on our devices, we have to use this subnet mask. Understood? So you see 0 is our network ID and 63 is the broadcast ID. So valid is from 1 to 62. Similarly, the second network will start from 64 and 127 will be broadcast ID. Clear? So now all of you, based on the same, try to calculate subnetting for 12 subnets. Do it fast. So your requirement is you want to divide in 12 subnets. Here the requirement was 4, and for you it is 12. Calculate.